Good morning. My name is Greg Davis. I'm with CBS ArcSafe. Today we're going to talk about remote racking and remote switching for General Electric Magnablast switchgear. Now, before we get into demonstrating any products, I just want to take a short time and discuss the various generations of things that we've seen for GE Magne Blast switchgear. The oldest version had either a single or double crank with a shroud cover, what we call paddle defeat style racking mechanism, which used a 3/4 inch drive socket with a donut around it to be able to keep the flange up and keep the shroud up and keep the racking mechanism engaged. After that, GE made a version with a racking motor in the back of the cubicle with an optional place to rack the breaker with the shroud system with a regular tool. Then they went to a clip-in and a bolt-in motor mount, which is the M26, M36 versions, which we're going to discuss today. Now, you can also have what's called a Canadian version. We've seen that once in Louisiana in the United States, and it's also found across Canada. And the reason they did that is Canada wanted to have jobs for Canadians, and I don't blame them, so they had variations in the breakers and the switchgear to have a difference so that you couldn't just ship something across the border and use it. Okay. The Magnablast switchgear started first in around the circa 1950 area range, and the breakers were first made by General Electric, and then in about the late 1970s, General Electric put their first vacuum version in what was called a VVC. And you can find oil breakers in some locations that are equipped to go into a Magnablast M26, M36 style cubicle. So you could have an oil breaker in one of these things, you can have an air breaker in one of these things, you can have a vacuum breaker. Some of the things to note about vacuum retrofits: if you're going to get something done like that, I would encourage you to contact our sister companies, either Circuit Breaker Sales in Gainesville, Texas, or Circuit Breaker Sales in New England up there, Northeast, because when you get a retrofit done for a Magnablast, the breaker has to be weighted. Okay, and if it's not weighted, you can have a 3,000 amp breaker that you've racked up into place, and now it doesn't have enough weight to come down. Okay, and then you have to shut down a bus. You've got to add weights to the bottom of the breaker to get it pop off the tulips to get this thing come down, and then you got to send it back to go get the weights put on by the people that did the retrofit because they didn't do it right. The other thing that you need to know when you're doing retrofits is this: even though it says M26, M36 cubicles and stuff, General Electric at times moved the grounding plates in the back where the breaker would go back and engage to ground it, and so not all those are in the same place. So when I say contact Circuit Breaker Sales in Gainesville or Circuit Breaker Sales in New England to make sure that you've got the right equipment going in for a retrofit or even other stuff, they will check to make sure so that those grounding plates that are going to engage in the back are in the right place, and your breaker is going to be compatible with your specific version of M26, M36 switchgear. Now, to start our actual demonstration today, the first thing I'm going to do is talk about our RS-01 and our RS-2 HD. We made this first for a power plant over in northern Louisiana because they had a peaker unit, and sometimes the SCADA gear wouldn't shut down from the control room, and then you'd go operate the control switch and the control switch might fail. So now you're going to the face of the breaker to shut this thing down. So instead of us using our standard little solenoid, which was not enough, we developed a high strength actuator that's going to be able to push. Now I don't have the ability to charge and close and trip this breaker today, but I can still show how this works. So I'm going to pull up the RSO1. I'll tell you what I'll do. I'll put it down here so that we can see everything operate at the same time. Okay, so I'll turn it on. For this particular actuator, we have to have close AR selected, and we're going to push down the close button, and it's going to go in and it would actually trip the breaker like that, and you'd hear the bang. Now, the RSO1 as it is, while I'm standing right here, would not be the objective to have happen on live switchgear. This cable stretches out to 25 feet. If you need longer, we have radio remote options that can get you out to 100 meters. So you don't have to be anywhere close to this thing when you go to trip a breaker. And just understand that, okay? So I'll go ahead and turn this off. I'll get this disconnected now, and we'll work to do our RRS3 MB2 here in just a minute. All right, now while there's a lot of stuff here, everything here is important, and as I work to set stuff up, we're going to go through it and it'll get clearer instead of just look like a mass of wires and things right here. So the first thing is we have our motor. Our motor is wound for 120 volts DC. And one of the things to understand is this. In the Magnablast switchgear, you can have 48 DC, 120 AC, 120 DC, 240 AC, 240 DC. So you got 5 different control powers. Okay, Greg, your motor's wound for 120 AC. We've solved that problem because the supervisory link, which would normally be directly from the motor to the cubicle, is not associated that way. That supervisory link is going to go to the control box here for the RS3 MB2, and it's going to take and interpret whatever power the cubicle has so that it can figure that out for itself, and the motor is going to be powered based upon the control input you give it for either racking the breaker in or racking it out, up or down, okay? So if you happen to have, and let's see, let me get out of the way. Can you show this picture right here, Brian, right now? So this is a clip-in motor mount here that I'm putting my fingers on. If you have bolt-in motor mounts where these motors are mounted in the cubicles permanently, you can remove that and we will sell you replacement clip-in motor mounts that take 2 bolts down here and 2 in the front, and you simply work to align it then so that you can use the RS3 MB2. Okay, so we have that option. We've done that for several companies, sometimes selling 7, sometimes selling 30 replacement motor mounts for a facility so they can use the RS3 MB2 for all their operations. Okay, so I'm going to work to install the motor now. And just to let everybody see, there's 2 knobs on the bottom here. Those knobs are going to go in slots. And then I'm going to work to clip this in here so it stays secure there. And we've already lined up the front part so that when I pull the racking mechanism engage lever in, it's lined up as it's supposed to be. And then I screw down the knurl knob on top. Can you see that now, Brian? I don't know if you can or can't. I was going to say I'll put my hand up here, but it's right up here at the front. Okay, so now after we've done that, we're going to start hooking things up to the system. So the first thing I'm going to hook up is the power for the motor, which is going to be this cord. Okay, let me get that through, out of the way now. So we've got our connection here for the motor, and it's got a little keyway up at the top, that's going to go right here. That's secured now. Next, we're going to put the supervisory link. So this is the standard General Electric plug, which the motor would normally have on itself. If it was a regular standard GE clip-in motor, it would go from here up to the socket there. And you can see that you've got the part in the middle of the neutral is slightly high. So you could try and screw this up, but it's only made to go in with this in the upper position. So we're going to go ahead and plug that in here. And we've got that connected. Now, a couple things to discuss about the switchgear, whether it's M26, M36. There was a version where you had a control switch in here to operate the motor from the control switch up high, or you had what looked like a breaker control switch to be able to do that. And so we actually have a chicken switch version of the CSO1 that would operate the breaker control switch version. Okay? With the other version where you had the manual select switch, which sort of looks like a small molded case circuit breaker, you'd simply put it in the position you're going to operate it, and when you're ready you would operate the RS3MB2 like it is. So we've worked to accommodate and figure out how to solve these problems based on various variations people may have in this switchgear. Okay? Now, one of the unique things that nobody else has for racking the RS3 or the Magnablast breakers is a tilt switch. And what I'm going to do is I'm going to turn on my unit now after I get power to it here. I got to unplug my RS1 for just a second. Okay. All right, now I'm going to go power on local, and I'm going to zero out my tilt switch here. I'm trying to. There, I got it silent. So any variation of 10 degrees is going to set the tilt switch off. So when I put this on the front of the breaker like this and I zero it out, okay, you see the light starts going off. If I rotate it just 10 degrees any direction, front, back, left or right, that's going to happen. And the reason we came up with the tilt switch is this. Many times people have had Magnablast switchgear over the time, if they have not been doing proper maintenance on the cubicles, slip a gear. Okay? And our chief scientist and CEO, Finley Ledbetter, said, I always want the operator who's installing or removing the breaker to have full control over that operation. He can be alerted on this stuff and he can work to select the opposite direction. It's not going to be an automatic feature where the thing says, oh, tilt switch has gone off, I need to go out. It's not going to do that. It's going to be up to the operator to know, hey, the tilt switch has gone off. I need to stop the operation and reverse it, or just simply stop it based upon what the company who's purchased the equipment decides they want for a standard operating procedure. Okay, so that's just one of the things to understand. And so if you have that chain slip happen, I've talked to people who've had it happen before and stood there and listened to a Magnablast breaker just grind its way up. And they knew something was wrong, but they just didn't stop, okay? Because they had their hand in the cubicle in the old style where you just held the charging lever down and let whatever happen, going to happen. So the whole reason for this is to let you know you have a problem and that you can do something about it, okay? So this also happens to have an option for a radio remote, which will get us out to 100 feet for wireless control if we want to do that. Now, if you look at the display here also, okay, Brian, I want you to zoom into this part, please. Okay. We have type 1 and type 2, and so when we're doing this, okay, this is how we know which type of cubicle we need to operate. So if we're operating the type 1, which is what this is, where we just use the supervisor link, we leave it in type 1. If we have the breaker control switch, the knob switch, or what looks like the big molded case breaker switch right there, then we put it to type 2. And what it does is it switches the internal logic on the RS3MB2 to do that. Now the other thing that the RS3MB2 does is it can help you do diagnosis of the position switches, up and down position switches that are inside the cubicle. One of the things to note right here is normally on our standard CCM, okay, if we look right here, we have a dot between here, which is, this number is going to read out the current the motor's pulling as it racks the breaker up and racks the breaker down. This other dot over here is the mercury position switch in the cubicle that tells you whether it's down or whether it's up, and which would automatically shut the motor off to do that. Okay, so that's what that function is, and we have that functionality in the CCM on the RS1 and on the RS3 MB2. Okay, so at this point I'm going to switch it over from local to remote. Okay, and I've got this active. I've got the supervisor link in here. I've got my motor hooked up. I've got my tilt switch ready. And so at this point, I could step away and I touch the install button. Okay. And that goes right up until the time that the upper limit switch says I'm in. Okay, and then it automatically shuts off. Now if we look at our CCM on the RS3 MB2, we're actually on the upper position switch. And so it tells us we're installed there. You can see that your crush sensor for your secondary connection is made connected right there. So there's about 3 things inside this cubicle that all happen between the micro switch over here on the side, the second sensor up here for the cubicle switch, and the third one for the crush sensor that says, hey, this breaker's good. Okay, so you would then check it. Now, one of the funny things that I'll tell you is this. The original instructions for the GE Magne Blast switchgear said that you would elevate the motor, look to make sure the shutters are coming open, and then continue with raising the operation. Nobody I know of looks to see that that happens. What I would tell you is this: if you want to follow that part of the instructions, we also make a magnetic base mounted camera that you could put on the next cubicle door and have it look as it happens, so you could verify that you're not trying to crank through the shutter doors that are in the top of the cubicle. So we do have the capability for you to actually monitor that as you rack that breaker in. Okay, now for us to rack the breaker out, we simply touch the remove button. Okay, we saw a couple flashes of the tilt switch right there, and that's just because we didn't slip a thing or anything, but it's just a momentary thing. It wasn't continuous flashing, but it was alerting the operator that, hey, the breaker is just going a little bit wobbly, keep an eye on this. If it had stayed continuous on, it would have indicated that we did have a serious problem with the cubicle. The tilt switch is also an option for the RS1. We don't have it on the RS1 that we're going to show you in just a minute, but I want you to understand that is an option along with the Magnablast supervisory link for this switchgear. Now, as I work to get things switched over, I'm going to tell you, whether it's the RS3 for the MB2 or the RS1, if you've got questions on this or any other circuit breaker, give us a call, 1-877-472-3389, or send us an email at info@cbsarcsafe.com. So let me go ahead and turn this off, and I'll work to get everything disconnected here. And again, if you want to see if anybody's asking questions right now, Kyle, while I'm working to get this thing changed out, let me know. You'll still find a lot of this stuff around. The vacuum breakers you still see on a lot of peaker units where they've got VVC breakers is the designation. It was actually General Electric's first vacuum breaker was the VVC before they made the GE Power Vac. So you can find those out there today. They are still out there. So they are still being made. I've seen a lot of them. All right. Now this is our standard RS1, and this one's equipped with both a radio remote option and with the Magnablast supervisory link. So this will also integrate into the cubicle just like the RS3 MB2 to be able to operate the system, and it'll automatically read the position switches inside the cubicle. Let me go ahead and get the power hooked onto this thing while I'm getting everything else set up. Okay. So Let me get the motor out here real quick. Got that. Now, instead of having a motor on this, we have what's called our geared adapter and a little socket that goes on the end. This fits in here just like the clip-in motor would, in the same place. Where is it? Oh, I know the hole's right there. I'm just missing it. There we go. All right. Come on. Now what happens when you pull this clamp down inside there, that actually energizes the position switches inside the cubicle. So one of the things about whether you're using the RS3MB2 or the RS1 and it's reading the position switches, it's actually going to tell you whether or not your position switches are working. Now the original equipment for General Electric were mercury-based little electric switches, okay? Circuit breaker sales, whether in Gainesville or CBS NE, both have replacement non-mercury switches for the Magnablast cubicles. So if you want to get rid of those things, you want to get them out of there, they have those available for you in stock. Okay, just to let you know. So now we're going to turn on the RS1. We're going to raise our motor to get it up here to the right elevation. I got my motor brake off so I can line things up. Okay, go down just to here, come forward, break off. All right, now, whenever we're racking a breaker like this with the RS1, we don't let it just possibly go back and forth or anywhere. If it's a stationary racking mechanism like this, we'll push it forward, and we're going to lock our foot latches down so the RS1 becomes a stationary unit. Now, I don't know if you can see it or not, if you can focus down in on that, but this shows the same position switch indication that the RS3MB2 did, okay? So it can tell that it's hooked up to a GE Magne Blast cubicle at this time. And now if I hold this, and this is the funny thing, people sometimes pick this up and hold it like that. No, it's meant to be held like this. If the arrow points away from you, it's meant for install. If it points towards you, it's meant for remove, okay? So all I do is momentarily depress the button, and now it's going to go up. The RS1 is going to rack it slightly faster than what a man would do if he was going to do this manually. So that's one of the things to understand. The RS3MB2 is going to rack it like the GE electric motor. The RS1 is going to rack it about twice the speed that a man's going to do to get this thing in. I can tell what happened is we didn't check the make the clutch tight enough. We have a clutch wrench in here. That's what's happened. That's why it's doing that right now. Give me just a second. That'll do it. That's my fault, folks. I should have had that tighter. And it's reached the upper position right there. If we're going to remove it, we just push the remove button. And down it goes. So the clutch is an adjustable clutch that we work to try and make sure people aren't putting more force into the system than what's required. It's the same kind of clutch as you'd have in a little go-kart where you've got two spring plates against a flat surface. It's got an adjustment range from about 10 foot-pounds up to 40 to 50 foot-pounds of force. And we mechanically adjust it normally to show people that you want to use that so that you're not letting people just brute force breakers over and over again, because then you're losing the advantages of remote racking, okay? And I can give you an example. So 2 times in the domestic United States, I've run into breakers where I had to use the brute force mode of an RS1 to get a breaker out, because some guy had put this in and then he got to the end and went, ugh, and went that extra oomph just to show that he could put it in more. And so normally, like a PAL-VAC should take about an install value of about 18 on an RS1 and a remove value of 15 to 16. And I was working down in South Texas, and I had the RS1 set up with 24 foot-pounds on the clutch for the limit. The breaker's not moving. I'm like going, this is odd. I move it up to like 30 foot-pounds, and I'm using the CCM version where I've set in what I know should work for current levels. The breaker won't move. I took out the input settings and put the unit in what we would call beast mode, where it's just like we're going to let it run to its operating limits, where we could generate potentially 40 foot-pounds to get a breaker out. And so when I did that, you heard, because whether a man did this or the machine did it, the same thing was going to happen when this breaker broke loose. So you heard the bang as far as the release of energy in this bound up racking mechanism, and everybody behind me in this power plant just started to laugh. And I said, what's so funny? Randy put that one in. They knew who had done this. There was no question what Bubba in the shop had done this. And so after that, we decreased the value on the clutch, we decreased the value on the CCM to what it takes to put a PAL-VAC in. You know, for most of your Magnablast breakers, even though you're doing a lot of work raising these breakers, most of the time you're using less than 20 foot-pounds of force. So you'll see the CCM running for about 17 to install when you hit the bus, and about 12 to 14 for removing the breaker. And that can even be for the large ones, because the gearing in the cubicle gears down the amount of force required. It just takes longer. So with a small unit like this, it's about 96 turns on the screw. With the big breaker, it's almost 400 turns on the screw, just because of the gearing reduction inside the cubicle. If you guys have questions about this, please let us know. Again, 1-877-472-3389, or you can email us at info@cbsarcsafe.com. Any questions now, Kyle? Okay. Okay, I'd like to again thank you once again for tuning in today. If you need remote switching or remote racking for your Magnablast, please give us a call. Get us your pictures, get us your contact information. Lauren and Chrissy will be happy to help you out. We do have 4 field guys, Jamie Clark, Mark Standridge, John Waite, and Mike Sims, that visit most of our locations in the United States. We've got other people like Chris Pratt up in New England, Mike Smolin working sales up there, and we also have Rob Combs and Tim Conley working out in the Pacific Northwest area. So please get a hold of us. We got coverage all across the country, including Hawaii and Alaska. We'll get you taken care of.